Okay, today we're going to talk about functions and function compositions. And so we need to understand what a function is. Okay, so function is nothing more than an equation. So I have two equations here. I have 2x minus 5, and then over here on the right, I have x squared plus 2. Now, what I want to focus on is this function notation. Okay, so what I'm looking at is I can assume that's my expression or equation, and then this is the function notation right here. So f of x. On this one, the function notation is g of x. So all function notation is a different way to write y. But instead of writing y equals for both of these equations, since they're different equations, we use function notations to kind of give it a name. So this first equation is the function f of x. And then the second equation is the function g of x. So it's just a way to be able to name and identify two different equations so that we're not using the same variable, okay? Now, the other thing about function notation is this x value that is inside the parentheses is going to change. So we're going to actually fill in values for that with different numbers. And these are my input values. Okay, so think of a function kind of like a machine. So I put something into that machine or into that computer, and I'm going to get something out. So what I put into that machine is considered the input, and then the answer I get out of that machine is my output. Okay, so same thing over here. This x inside parentheses is considered my input. Okay, for instance, let's choose an easy number. Let's choose 2. If I wanted to find the value of both functions when x was 2, what we would say is, there we go. We would say f of 2 is equal to 2x minus 5, right? And so the input here is this 2 value. So what is that telling me? It's telling me that value I need to put into my equation as the x variable. Okay, so when I do that, I know that f of 2 is going to equal 2 times 2 minus 5. So again, the input value inside the parentheses, we replace every x in that equation with. Okay, and then simply from here, I just work this problem out. 2 times 2 is 4, and 4 minus 5 is negative 1. So f of 2 has a value of negative 5. And then once again, we have to understand that 2 is our input. And now our answer right here of negative 5 is our output. Oops. Okay, so it's basically nothing more than an ordered pair, right? If I wrote this as an ordered pair, the x value would be 2 and the y value would be negative 5. So that's all that function notation is saying, right? That's all we're doing. And so if I did the same thing for g, if I wanted to find the output for g when g, or for g of 2, then again, 2 is my input. So that means that I am going to take this 2 and put it in for that x. So then I have g of 2 is equal to 2 squared plus 2. And then I just work this out. 2 squared is 4. 4 plus 2 is 6. So for my function g of x, when I have an input of 2, right, input, then my output is 6. So again, I could also write this as an ordered pair. So think of it as f of x is one machine. It'll give me a specific output. G of x is a different machine. More than likely, it's going to give me its own specific value. Okay, so even though the inputs were the same, I got a different output value. All right. And so that's kind of what we are doing when we're finding function and we're doing function compositions. Okay, so I'm going to kind of bounce around on my notes and kind of start off with what I feel like is some of the easier things. Okay, so we're going to look at first A, D, G, and E. Okay, so A is just a problem that we just worked. We want to find J of 13. So what I look at for A is I find the function that is named J of X. Okay, so I use this function over here, and again, for J of 13, I substitute a 13 in for X, and then I simply just work this out. J of 13 has an output value of 16. Okay, so that's just kind of what I just showed you. All right, so now we get a little bit more complicated, right? I'm going to go to work E. So this says F plus H of 8. So what does that mean? So now we're just doing two compositions at the same time. What this is saying is I'm going to find F of 8 and I'm going to find H of 8, and I'm going to add those two values together. Okay, so the first thing we need to figure out is what is the f of x function, and there it is. So f of 8 would be 4 times 8 plus 2. All right, so I need to figure this out, so let's do that. 4 times 8 is 32. Plus 2 is 34. Okay, and then I need to find h of 8. So here is my function for h. So I have 2 times 8 minus 3. So that gives me 16 minus 3, which gives me 13. And then remember, I said I'm adding all of these together. So then all I need to do is 34 plus 13, which should give me 47. So f plus h of 8 is equal to 47. All right, so then we do the same thing if we're looking at D. This time we have f minus g of 5. So again, I need to find f of 5, and I need to find g of 5, and then I'm going to need to subtract those two this time. So again, the f function, 4 times 5 plus 2. 4 times 5 is 20 plus 2 is, so we have 20 plus 20, or 2 is 22. And then for g, here's g is x squared. So we have 5 squared, which is 25. So I have to subtract those two. So 22 minus 25 gives me negative 3 as an answer. So f minus g of 5 has a value of negative 3. And then g, again, I have g divided by h of 7. So I basically have g of negative 7 divided by h of negative 7. So then I got to work those two out, right? So again, I look at g. Right here is x squared. So that means I have negative 7 squared. Anytime we substitute, we use parentheses. So that gives me 49. And then for h, it's 2x minus 3. So we have 2 times negative 7 minus 3, which that gives me what? Negative 14 minus 3, negative 17. So 49 divided by negative 17. Let's see if that simplifies. And it doesn't, so we can just leave it as negative 49 over 17. If you wanted to convert it to a decimal, it comes out to about 2.88. Okay, so those are a little bit more complicated, right? A little bit more complicated compositions. So those are what we consider compositions. We use our functions with values to find out a given value. Okay, so now what I want to look at, we can come back to some of this, is seeing this on a graph. Okay, same concept, right? So if I look at problem A right here, right, we have f plus g of 3. So what that's saying is I want f of 3 plus g of 3. Okay, well, here's where things get complicated. Okay, instead of giving us an equation, they give us a graph. So it says that f of x is the parabola. So we have to understand what the parabola is. So I'm highlighting the parabola in yellow. And also I am going to label that f of x. Okay, so if that one's f of x, it says g of x is the line piecewise function. So this in light blue is g of x. Okay, so again, it just kind of gives our two graphs a name. Okay, so for part A, if I'm finding f of 3, remember all these things are ordered pairs. So f of 3 tells me that I have an x value of, I'm just going to kind of write that down here, an x value of 3, and my job is to find the y value associated with that for the f of x function. So I'm going to draw a dotted line. This is when x equals 3. And I have two intersection points. Okay, the one I care about is the one attached to my f of x function, my parabola. So that y value at that specific point is 5. So again, remember 3 is the input, 5 is the output. So then for my f of 3, that has a value of 5. And so I have to add that to my g of 3. So again, on g of x, the input is 3. This time it intersects g of x at this point. So what is the output value? The output value is 4. So then g of 3 is equal to 4. So then all I have to perform is 5 plus 4, which equals 9. So A has an answer of 9. Okay, so then I look at the next ones. Okay, accidentally unhighlighted this. Okay, so then let's look at problem B. This time it has f minus g of negative 2. So again, I need f of negative 2. Then it's going to be minus g of negative 2. So I need to find those values, right? So again, I look at f. So let's draw at negative 2. Here's a vertical line. There are 2 intersection points. Okay, both of these points on the f of x function, the parabola, that value is at 0. So then this value is 0 minus, and then for g at negative 2, that value is an actual 2. So this is 0 minus 2, which gives me negative 2. Okay. And then we can continue on, right? So now this is f of 0 times g of 0. Okay. And so now again, I have to find 2 values. Again, here's when x is 0. And I'm just looking at basically the 2 intersection points. So this one's at 0, positive 4. This one's at 0, negative 4. So f of 0 is negative 4 times g of 0 is positive 4. Negative 4 times 4 is a negative 16. And then again, now we're kind of on a roll here. So I do f of 1 divided by g of 1. So here's x of 1. It's a vertical line. There's where it hits my 2 graphs. So we have 1 comma negative 3 for f of 1. So this is negative 3 divided by, this is 1 comma 4. So g of 1 is 4. So we basically have negative 3 divided by 4, okay, or negative 0.75. All right, so that's kind of how you do those straightforward ones. And then I really want to concentrate on these right here, these 2. Okay, so we have, and actually these are all the same type, okay, of composition. If you see where it has a composition, bam, that means the same thing. So we're going to concentrate on G, problem G and J first. So notice we have, this says f of G of negative 1. So when we do this, think about orders of operations. We always focus on the inside of parentheses first. So the first thing we're going to do is G of negative 1. So that's the first thing that I have to find. So at negative 1, where does this intersect g of x? So it's at negative 1 comma 3. So g of negative 1 has a value of 3. Okay, so once I find that, now my job is to find f of 3. So then again, I come over here and I have a vertical line at 3. Where does it intersect the f graph? That value is 5. So f of 3 is equal to 5. So that means this entire composition is 5. So we always work from inside out with compositions. Okay, so let's try problem J. This time we have G of negative 3. So I'm going to only do g of negative 3. So g of negative 3 has a value of 1. And then I'm going to do g of 1, which has a value of 4. So it has an output of 4 now. So g of negative 3 has a final output of 4. So we're just kind of doing two problems in one when it comes to this. Okay. And so h and I are basically the same thing. It's just written a little different with this kind of like open composition dot. So we basically can say g of f of negative 3. And again, what am I doing first is this f of negative 3. So I do f of negative 3. So here's negative 3. I need to make sure that it is on the f function. So that gives me a y value of 5. So then this is 5, and now I'm finding g of 5. So then here's when x is 5, and it intersects g at 3. So my final answer for this is equal to 3. Okay, and then the last one, we have f of negative 2. Again, I'm going to do f of negative 2 first, just that inside part. So here's negative 2. It intersects f at 0, right? Value of 0. So then I need to do f of 0 next. So then there's 0 intersects f at negative 4. So this answer is negative 4. Okay, and so that's how you do it when you're given some graphs. All right, so again, now coming back to something that's a little bit more difficult. Okay, again, we have f plus g of x, but this time it gives us equations again. Okay, so again, I'm going to have f of x plus g of x. Okay, so what is f of x? F of x is represented by x squared plus 1. And then I'm going to add g of x, which is represented by 3x minus 5. Okay, so again, I like to put parentheses around this stuff. And then I just combine like terms, if there are any. So I have x squared plus 3x. And then my two like terms are positive 1 and negative 5. So that gives me negative 4. So my final answer is x squared plus 3x minus 4. Remember, we're just simplifying here. Part B, same concept. I have f of x minus g of x. And so I'm going to do x squared plus 1 minus 3x minus 5. And then in order to start solving this one, we can't forget I need to distribute that negative. So then this side remains unchanged. And here, negative 1 times 3x is negative 3x. Negative 1 times negative 5 is a positive 5. And then again, I just combine like terms. So I have x squared minus 3x. Like terms are plus 5 and plus 1. So I have plus 6. So x squared minus 3x plus 6 would be my final answer for part B. I'm going to do D next. D, we're saying we're going to have f of x divided by g of x. So f of x is represented by x squared plus 1. And we're going to divide that by g of x, which is represented by 3x minus 5. Here, I can't really simplify anything, so that's my final answer. And then part C, we have, again, f of x times g of x. So f of x is x squared plus 1. And then we're going to multiply that times 3x minus 5. And so then here, we need to talk about how do I multiply two factors, okay? Well, in order to multiply two factors, okay, this is just distributive property. I'm going to take the first term, and I'm going to multiply it by both terms in the second factor. So x squared times 3x gives me 3x cubed. X squared times negative 5 gives me negative 5x squared. Then I'm going to take the second term in that first factor, and I'm going to multiply it by both terms in the second factor again. So this time 1 times 3x is 3x, and 1 times negative 5 is negative 5. And then if I can combine anything, I combine. In this case, I can't. So I leave that as my final answer. And then this is where it gets tricky. Okay, so remember E is basically saying f of g of x. Okay, f of g of x. Okay, this time I don't have a value, I just have a function. So I need to take one function and put it into the other function. Okay, so this is saying that g of x, I'll highlight it, g of x is my input for f of x. Okay, so what do I mean by that? Let's come back up here to my problems. G of x, I circled everything here in red. 3x minus 5 is represented by g of x. This is going to be my input. I'm going to input it into f of x. Okay, I'm going to input it into f of x. So what that's going to look like, let's see if I can do this. F of the input is going to be 3x minus 5. And so this is f, x squared plus 1. Well, instead of saying x squared, I am going to erase the x, and I'm going to do a set of parentheses, and I'm going to input 3x minus 5. So I put g of x into f of x. And now I have to work out that part. So this says 3x minus 5 times 3x minus 5, because it's squared, I write it down twice, plus 1. And so again, I have to multiply. 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. Negative 5 times 3x is negative 15x. Negative 5 times negative 5 is a positive 25. And then I still have this plus 1. Then I simplify if I can. 9x squared minus 30x, combine like terms there, and then plus 26. So this is f of g of x. So that was inputting g into f of x. And then f is the other way around. I'm going to take f this time, and f is going to be my input. So I'm going to take x squared plus 1, and I'm going to input it into g of x. So what's that going to look like? I'm going to have g of x squared plus 1. So that's going to be my input. And so g of x is represented by that, 3x minus 5. I leave a little space because I know I'm going to erase the x, and I'm going to substitute f of x into it. And then I can start solving this. I distribute. 3 times x squared is 3x squared. 3 times 1 is 3. And I still have the minus 5. And then I can combine like terms or simplify. And so this is my final answer. G of f of x is equal to 3x squared minus 2.